Hello and welcome. Today we're going to be looking at the unit test for series, one of the topics in Precalculus. As always, we're going to be going through all of these questions to help you understand how to approach and solve the questions on series in this topic. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here we go. Okay, our first question, j equals 0 and it's going to 1. And that notation right there, that little like s kind of thing, that's a sum, right? So we're adding. It's cumulative sum. You start at 0 and you just keep adding onto it. And 2j minus 4. Okay, so if I plug in 0 and I get negative 4. And then I plug in 1 and I get 2 minus 4, negative 2. And I'm only doing 0 and 1, right? I start at 0 and at 1. That's it. That's what it means. So negative 2 plus negative 4 is negative 6. And that's it. That's the whole thing. Not that hard, was it? All right, now we're going to do something using the binomial theorem. All right, so let's see what we can do with the binomial theorem. All right, so with the binomial theorem, what does that mean? What does the binomial theorem mean? Well, it's just a way of expanding out some kinds of things, right? So let's assume for a second that we had just z plus k, right? So z plus k by itself. Now z plus k to the 1 is going to equal z plus k. 1z plus 1k. The same way you have a 1 and a 1 right here. Now if I do z plus k squared, I have z squared plus 2zk plus k squared. The 1 plus the 2 plus the 1. The coefficients are going to be like this. Now the row 4, which is what we care about, since we're raising this to the 4th power, row 4 right here, row 4 is going to look like 1, 4, 6, 4, 1. So if I were going to write that down, I would write it down like this. So it's going to be the first term, 2z to the 5th, plus, let's actually have 2z to the 4th times 5k to the 1 times 4, plus, and then I have 6 times 2z to the 3rd, or sorry, actually, this is 2z to the 4th at the first one, and then 2z to the 3rd, 5k to the 1, and then 2z to the 2nd, 5k to the 2nd. And make sure, like right here, it adds up to 4, right? So make sure you're only going to each one of the powers, the degrees adds up to 4. Right? That's my mistake. I'm writing on a notebook if you couldn't tell. So, and I'll show it to you in a minute. So 2z and then 5k to the 3rd, and then just you have by itself you have the 5k to the 4th. All right, so this is what it looks like. This stuff right here, that's what it looks like. Right, you have the 2z to the 4th plus 4 times 2z to the 3rd, plus the times the 5k, and where is it? 5k, and then you have the 6 times 2z to the 2nd, 5k to the 2nd, and on and on. And now we just figured out what that is and add it up. 2z to the 4th, that's going to be 16z to the 4th, plus 4 times 2 to the 3rd times 5, 20 times 8 is 160, times z to the 3rd k. All right. Now you have 2z squared plus 2z squared times 5k squared, which is going to be what, 600, because you have the 6 times the 2 squared times the 5 squared, z squared, k squared. And then you have 4 2z times 5k cubed. 5 cubed is 125 times the 4 is equal 500 times the 2 is 1,000. So you have 1,000 there. That's going to be by zk cubed. And then you have 5k to the 4th, 625k to the 4th. And that's that. Let's keep going to the next question. All right, Marco went on a hiking trip. The first day he walked 24 kilometers each day since he walked a third of what he walked the day before. Which expression gives the total distance Marco walked in the first n days of his trip? So since we have a ratio that's going down, we're going to do 1 minus 1 over 3 to the n over 1 minus 1 over 3, right? That is what it looks like. But this is right here, this one, right? A. That's what it's supposed to look like. right? Instead of having the 1/3 to the n minus 1 over the 1/3 minus 1, you flip both sides because you can do that, right? You just multiply both sides by -1. You get 1 minus 1/3 1 minus 1/3 to the n over 1 minus 1/3 times the 24 that he started with, right? None of the rest of these are right because they don't have this common ratio of 1/3. And that is that for part. That is that for question number 3. And we can move on to the next question. And arithmetic sequence is defined as follows. A1 equals negative 138. AI equals AI minus 1 plus 6. So essentially, you have negative 138, and then negative 132, and negative what, 126, and on and on and on. Right? So essentially, what you're doing is you're doing negative 144 plus 6i. Right? So for A1, that's going to be a negative 144 plus 6, negative 138. For A2, it's going to be negative 144 plus 6 times 2, plus 12. Right? So that's how it's going to be. So for the 35th term, I pull out your calculator. 35th term is 6 times 35 plus 144. Minus 144. It's going to be 66. So we started at negative 138, and we're going to 66. All right, now how are we going to deal with that? Okay, let's think. Well, since the arithmetic sequence goes up by the same amount every time, that means that if we add the last two terms, if we take the average of the two terms on the ends, we can find the actual average. So negative 138 plus 66 divided by 2 is negative 36. Negative 36, that's our average. And you have 35 terms, so negative 36 times 35 is going to equal negative 1,260. That is the sum of these terms, negative 1260. That's it, right? Nice and easy. Let's keep going. Find the sum of the geometric series. Well, we just saw that you have, what you start with, which is still 1 here. So then you have 1 minus 0.8 to what? Well, if you're doing it usually, you would do 0.8 to the 20th minus 1. So now 1 minus 0.8 to the 20th over 1 minus 0.8. Now I'll pull out my calculator again, and we're going to compute this. 0.8 to the 20th, that 2, and that's going to give us 4.94. So our answer is 4.94. And we can keep going to the next question. Nice and easy. Find the sum. So I can split this up into two parts, okay? So I have the 131 part, and then I have the negative 4k part. So for the 131 part, I think that's kind of obvious, right? You have 50 different terms, k1 to 50, so that's going to be 131 times 50, which is going to be 6550. Then you have the negative 4k. Now, if you were going to add k from every number from 1 to 50, you would do 1 plus 50, so 51, and then there's 25 pairs of that, so 25 times 51 is going times 51 is going to be 1275. 1275. That's the sum of all the numbers from 1 to 50. I'm doing that by 4, so that's going to be 5100. And then you're subtracting that, so that's going to be minus 5100. So 6550 minus 5100 is going to be 1450. 1450. That is it. That is all there is to it. 1450. Let's keep going to the next question. Okay, that's literally it, right? So you have n. So 0 plus 1 plus 2. That equals 3. So 3. It's common sense, right? Like that's how sums work. You can start like small, you can start just understanding the concepts and building up. Right? That's how you keep getting better at it. That's how you keep learning more about it. Right, anyway, geometric sequence defined there. So you start at an 8, you multiply by 3/4. So our the way we're gonna write this is going to be we have 8 starting at 8 times 1 minus 3/4 to the 25th, right? Because the first term is 8, second term is 8 times 3/4 to the 1, so the 25th term is 8 times 3/4 to the 24th. So we go one more, so 8 3/4 to the 25th to make it in the formula. And then the bottom is 1 minus 3/4 as usual. And then you're going to do 3/4 to the 25th, 1 minus that over 1 over 0.25. And then you multiply that by 8. And you get 31.98. 31.98. And so that is our answer. And let's keep going. A monkey is swinging from a tree. On the first swing, she passed through an arc of 10 meters. With each swing, she passed through an arc 9/10 the length of the previous swing. What is the total distance the monkey has traveled when she completes her 25th swing? Must be a dedicated monkey, I gotta tell you. Like, honestly. 25 swings. My arms would hurt. Right? Then again, I don't have a monkey's. I don't even know what they have to not get hurt. But pass through an arc of 10 meters. So that's why you're starting at 10. And then you have 1 minus 9/10. So you're starting with 9/10 to the 0. So the 25th swing is going to be 9/10 to the 25th. That's what it's going to be in the formula. And over 1 minus 9/10. Right, so a good way to remember this is that if the first term, right, has whatever that thing is to the 1, the ratio to the 1, then the nth term is going to have the ratio to the n. So the formula is going to have the ratio to the n plus 1. Now, if the first term just is by itself, and then the second term has like that thing times ratio to the 1, like so if the second term is where you apply that thing, then on the nth term, you'll have the ratio to the n minus 1. So when you're doing the formula, it'll be the ratio to the n. Just a nice way of remembering it. Right, so we have to compute that. 9/10 to the 25th, 1 minus that, over 0.1, times another 10. That's going to be 93 meters. Decent amount of distance, 93 meters. That's the total distance the monkey has traveled when she completes her 25th swing. And we can keep going. All right, so that was the topic on series and on precalculus. That was the whole unit test. I hope you have a better understanding of how to deal with these series, how to approach and solve these kinds of problems. I'll see you next time we continue looking at more of these precalculus topics. Until next time, I'll see you then.